Welcome to another GC Basic demonstration. This is part 7. We're going to make some LEDs flash in a sequence with reverse. Magic's going to happen. This set of videos is for 16F, but it can be used on the 12F and 10F just to make the changes. But the same capabilities exist across all the chips. Up to this point, let me think, up to this point, you can use this on the newer chips as well, because we've not used any capability that's not in legacy and the newer chips. So please like and subscribe to this video, let it run all the way through and listen to it, or mute it as such, but to give me a thumbs up. So number 7, let's get straight into it. I'm assuming that you've got the GC Basic software installed. You can program it, you've tested that PIC, and you've got LEDs, a potentiometer, and you have some switches, because we're going to use all those now. Up to now, we've used them independently, but we're starting to build up what I would call I call the low pin count board. It's a demonstration that Microchip used to publish. They no longer publish because they can't afford to put 4 LEDs on a PCB, and it used to be the default. So it's in my brain, it's the default to get to. I'm using this type of board. It's a PIC Dem2 Plus board. Cost on eBay £15 British sterling, so very cheap. Lots of capabilities. So we're going to be using number 9, the 4 LEDs at the top there. Just below it, number 6, the potentiometer. We have a big chip plugged in. It's a legacy chip called 16F1937. Could have been any chip, I don't care. It's just a legacy chip. We're using some of the buttons at the bottom in number 7. The board looks like this. Nice little board. Hey, see my screwdriver? Nice board, a bit dark, but that's because I want you to see the LEDs. If I push this button here, you can just about make out the LEDs if I zoom in, and we'll look at that in a bit. So what we're going to do, this is the chip. What we're going to do is we're going to use all the things that we've used up to date. Master clear, we're going to use the ADC on RA0. We're going to use the switch on RA4, 4 LEDs, and some commands to make it all work. So this is the documentation that you'll find in the source program. Switch and ADC on port A, 4 LEDs on port B, and on port E there is the reset or master clear. So what we're going to do is we're going to rotate the LEDs in sequence. We've seen that done 2 videos ago. A switch will control the direction of the sequence. We're going to have the master clear as an input, not as a reset. The ADC is going to read the voltage from the potentiometer. We're going to use that in the wait command to be consistent. As I've said, that's consistent across all the frequencies. So if whatever this is defaulting to, I think it might be 32 megahertz. If you selected 1 megahertz, the wait time would be as accurate as it could be as it is calculated. So we're going to put the whole thing together. We have inputs, outputs, ADCs, and time, and a bit of rotation. And it looks like this from a flowchart standpoint. I'm going to initialize, and for those who are following along, the initialization process is setting up the chip frequency for you. It sets up the ADCs as digital ports or analog ports as required, and other things that we have learned along the years specific to a particular chip. If there's a known bug that Microchip have published, we will then include that for you. You don't have to worry. We shouldn't have to worry. And if we've missed it, let us know and we'll include it. Then we have a loop in our program that goes do it forever. And it says read the ADC. If the switch has changed state, move it to the left or to the right. And we're going to use a rotate in the set state of the LEDs. So we're going to do it slightly different depending which direction it is, but it's going to move the LEDs to the left or move the LEDs to the right using the rotate command. This is, as I said, the classic demonstration for microchip. I'm going to go straight into the editor, the GC code, and I'm going to press the top right hand corner, Explorer, open up the list of files, and I'm going to hunt down here. I'm going to set the filter up. First of all, Control F, GCB, set the filter, click that little triangle, and then it will only show me what I'm looking for. So it says here 90 reversible LEDs with variable delay, commonly known, as I said, as the LPC demo. Control B to get rid of that little window. In the header, nothing has changed. It's the same header. Specify the chip, option explicit, series of constants, and those that are now locked in, we have those set, we haven't changed them because they don't change. And here we are into a program. Let's have a look what we've got. So we need a variable that's called direction. We need to know which direction are we going, to the left or to the right. So we set that as a bit, and that only, and the system, the compiler system, works out that that's a bit, and it puts it in a particular space in your RAM and deals with it as a bit, and it can only be set to 0 or 1. My delay, which is going to be our delay period, is a word, it's a big number. It's greater than 255, but less than 65,535. And I've got this variable called LED port state as a byte, and I'm going to use that to store the state of the LEDs and then set the whole port. If you want to know where this code came from, I didn't write this code. An AI engine wrote this code, I think in December 2024. It wrote the whole thing. Hence, it's really very nice. I'm very impressed. So, two constants that we're going to use is LED right, LED left. They are obviously what they're used for. Is it going to the left or to the right? And then we set our direction to an initial direction of LED left. And we set the initial state of the LEDs of this variable called LED port state that we're going to be using. We've seen some of this before. I'm going to ignore the do loop because that's pretty obvious, right? We are going to read the LED, get the value from an ADC port, and we're going to put it inside of something called my delay. And it's going to end up in the range of 50 to 1000. Equates to 50 milliseconds to 1000 milliseconds, which is a second. And then we set the port. We can set the port. Done. We do a wait. We do a wait, and then we figure out what's going to happen next. Well, in our flow diagram, we said, has the button been pressed? If the button has been pressed, then change the direction, because we're using a not statement here. I'll make it quite clear and put that as a not statement, and it will just toggle it from 0 to 1, 0 and 1 very quickly. So if this button's been pressed, then we'll change the direction. And if you want to check what that button is, that's RA4 as a constant, okay? Then we have some logic, some great logic. If the direction is to the left, then do something. It says, well, just check to see if we're actually at the end of our LED run. And if it is, set the C. And we actually use this to set the C. Remember, we spoke about C in the past. This is the carry flag. So if we set LED port state here to 0, we're at the end of our run, and we set the LED and we set C to 1, and then we do a rotate, it rotates it into our first position, into our first LED. So next time round, it will set it. And the opposite of that is if the direction, therefore, is else, which would mean it's going to the right, we rotate it to the right, and we do the test we used before. We clear the carry flag, we rotate our value from 4 to 2, next time 2 to 1, 1 to 0, set the carry. If the carry is set, then carry equals 1, then we know we've got to reset our variable. And then we set our little cache LED port state to 1, and it will reset it. It will go round. It will look like it's going in a circle, but it's just coding. So let's have a look at this operating. I'm going to take the top right hand up here, which is the same as pressing function key F5, top right, make hex and flash. It's now flashing it out. We'll go to desk cam. Have I gone to desk cam? No, not yet. Desk cam, Zen mode I wanted to go to. It's programmed it. And if you look really carefully, I'll zoom in as much as I can. The LEDs are rotating. Is that a different direction? There we go. Let me just move that up and zoom in one more. The LEDs are rotating. If I push the button, they go in the other direction. That's going to the right. Push the button, going to the left. And back. Look at that. Remarkable. No, it's what we expected. I'm now going to rotate the potentiometer, and you can see I don't want to do it too much because you'll lose the visual persistence on the camera. Then moving to the left, moving to the right, left, right. It's doing what we're doing. So what we've seen, we can control a variable which sets the port. We can rotate that left and right. We can check the carry flag. There's so much that we've covered in these few videos with a potentiometer, 4 LEDs, and a couple of switches. We barely touched this board, but we're going to touch an awful lot of it shortly. I think that's all I need to show. Next time, we're going to be using serial. This is a diverge. This is where legacy chips change from the newer chips. We're going to use the serial on this particular board to display the values of what we're just looking at. There's a slight divergence. It still all works very from a GC standpoint, GC basic standpoint. It looks the same, but there's other things you'd have to set. But let's get into that in the next video. So this was part 7, make the LEDs flash in sequence and with reverse, which we have seen. Enjoy.